Algebra 2, 6.7, day 1, inverse
In.
relations. We are going to take graphs, and we are going to graph the inverse of each relation.
Uh-huh.
Now, we're not saying they're functions or not, we're just graphing, finding the inverse. So if this relation is -2, -3, -2, -3 is that point right there. -1, -2, 0, -1, and 1, 0. Now, it does not say connect the dots. These are, this relation, it's not an equation. It does not say y equals 1x minus 1. If it said y equals 1x minus 1, then you can connect the dots. But this relation is just these 4 points. Done. So that is the relation -2, -3, -1, -2, 0, -1, and 1, 0. How do you graph its inverse? I'm going to use a different, I'm going to use a blue marker. How are you going to graph the inverse of -2, -3? What's the inverse of this? It'd be
-3, -2.
-3, -2. So 1, 2, 3, 1, 2.
-2, -1.
-2, -1.
-1, 0. 0, 1.
Okay,
Yay.
good. Number 2.
Fight it.
Let's graph each of these 4 points. 0, -3. 1, -1. 2, 0. And 3, 2. I'm sorry, 3, -2. Now, do not connect these dots. Do not connect them. We're going to graph the inverse of these 4 points. So what's the first? -3, 0.
-3, 0. -1, 1. 0, 2. -2, 3.
And number 3. -3, -1. -1, 0. 1, 1. And 2, 1, 2, 3. Do not connect these dots. The inverse would be -1, -3.
0, -1, 1, 1. 3, 2.
Now, does anyone see anything happening? See if you could guess what is going on with these inverses.
Or like opposites.
Yeah, kinda, no, it's not really opposite, but
Or like
it can't,
flipped kind of.
it's a reflection
Yeah.
over the line y equals x. Whoops, sorry, I didn't draw that very nice. If you were to take this graph right here and flip it over the line, this is the line y equals x. This is a reflection of these points. These blue dots are a reflection of that. So same with this. If you were to draw an imaginary line, the line y equals x, do you see that these 4 points mirrored? If you were to fold your graph on this line, kind of on a diagonal, 45-degree diagonal, each of these points are reflected over that line. So this is the reflection of that point, this is the reflection of this one, and so forth. And same with this. If you were to draw the line y equals x, each of these points are reflected. Now this one landed right on the line y equals x, but that's a reflection of that, that's that, that's that. Wanted to see if you could find that yourself. Okay, the last 6, they want you to find the inverse of the relation, and it's written in an equation format. So, how do you do inverse? Now this problem could also have been written like this, f of x equals x plus 2. These mean the same thing. So what does inverse mean? It means you switch your x and your y. And now you're gonna rewrite this as, resolve this for y. So subtract 2. So x minus 2 equals y. And now, you can't keep these both as y. Y is x plus 2, and this is y is equal to x minus 2. They're not the same thing. This is the inverse, so we use this fancy inverse notation. Instead of writing y, we're going to use f negative 1x is equal to x minus 2.
That's the answer?
Yep, that's the answer. So this one could have been written as f of x instead of y is equal to 3x plus 3. These mean the same thing. Now, how do you write inverse? How do you do the inverse? You're going to change your y to your x is equal to 3y plus 3. And now resolve for y. So subtract 3. And never leave a y value with a number other than 1. So you have to divide everything by 3. So 1/3 x minus 1 is equal to y. This is the inverse of this. So instead of leaving it as y, what are you going to rewrite here? Instead of y, what are you going to write? F negative 1x. You get this? Hopefully. Next one. Now this is f of x is equal to 2x minus 1. How do you find the inverse? You're going to write this as x, switch the x and the y around, and resolve for y. How do you get y by itself? What do you do with this minus? Add 1.
X plus 1 equals 2, y divided by 2.
So y is equal to 1/2 x plus a half. Now instead of writing y, what are you going to write? Questions? Anybody? Okay, what would you do here? What's another name for f of x? Y is equal to 1/6 x. Now switch your x and your y. How do you get y by itself?
Divide by 1/6.
Let's, instead of divide by 1/6, let's multiply both sides by 6. So y is equal to 6x. And instead of leaving this as y, let's write this as, because that means it's the inverse. Do we want this to be a positive 1/5 or a negative 1/5?
Positive.
Positive? I think it's supposed to be a negative. It is a negative. Chris, am I still on the screen? Yep, okay, it's negative. So this is saying y is equal to negative 1/5 x plus 2. How do you find the inverse? What do you do?
Subtract 2.
Well, first change them, right? And yes, you're right, subtract 2. So x minus 2 is equal to negative 1/5 y. Now, do you know how to get rid of this negative 1/5? Yes, good job. Taylor, multiply everything by negative 5. Negative 5 times x and negative 5 times negative 2. So can you clean this up for me? You get negative 5x. What's this? What's negative 5 times negative 2? 10 is equal to y. Now, is there a better way to write this answer?
Equal f
instead of y, right? And the last one. That's what that says. How do you find the inverse? Switch x and y. And then what? How do you solve for y?
About it, right?
Minus 3. And then what? I don't want negative y, I want positive y. And what's a better answer? Instead of writing y is equal to negative x plus 3, what's a better answer?
Negative 1x.
You get this, guys?
Yeah.
That's your homework. Now tomorrow, we're gonna review this, and then we're going to do, what do these look like? Do you remember when you have an x and a y value, and the x value squared, what does this look like? It's a U-shaped figure. So we're gonna find the inverses of the parabolas.